go. So who have I not called on yet? Derek. Derek, this one here, is this left-tailed or right-tailed? You can just type it in the chat if you want, or unmute yourself and tell me. So to get to the chat, you go to more, and then hit the chat. Left-tailed. So my mean, okay, so don't forget, this is to help you figure these out, you draw a little fish, right? And he's already eaten the smaller one because the smaller one's easier to catch. The bigger one is when he's still trying to eat. So here, the mean, he's still trying to eat the mean, so the mean is larger. So here the mean is larger than 43. So if I say my mean is larger, then is this left-tailed or right-tailed? Derek, I'm asking you. So this one would be right-tailed. Now this next one over here, Rosie, what do you think this one is? Rosie O. Left-tailed. Yep, less than. My mean is less than 26.4. This one over here, Gina, what did you get for this one? Two-tailed. Yep, not equal to, greater than or less than. And then Sterling, what did you get for this one over here, this last one?
Left-tailed.
Left-tailed, perfect. Left-tailed, excellent. Okay, good. The rare event rule. Jocelyn, can you go ahead and read for us? Either Jocelyn or Juan, either one.
Sorry, can you hear me?
Yes. Perfect.
Okay. Rare event rule. If under a given assumption the probability of a particular observed event is exceptionally small, we conclude that the assumption is probably not correct. In other words, if it is unlikely or unusual, then our assumption
H naught. H naught?
H naught is wrong.
Great, thank you. So in other words, for example, we had 7 red cards in a row. The probability of getting 7 red cards, so we're assuming, first of all, we assumed that my deck was a regular deck, right? So if we assume that my deck is a regular deck, then the probability of getting 7 red cards in a row is really unusual, really small. Then we conclude that the assumption is probably not correct. In other words, my deck is probably not a regular deck. So another way of putting that is, if what we get is unlikely or unusual, then our assumption, H naught, is wrong. H naught said that my deck was the same as everybody else's. My proportion was 50% red cards. That's wrong. So that's what you do. If you get something unusual, then H naught is not correct, because you should not get something unusual. So here's our steps. The first step, write your claim using one of these symbols. Either your mean is greater than, less than, equal to, or not equal to, or your proportion is greater than, less than, equal to, or not equal to. Then write down what H naught is. H naught is always, always, always no difference. So H naught is always, always, always equals. Always equals. So it's either going to be P equals something or mu equals something. It's always going to be P equals or mu equals. So this is the top of your page 10 notes. You don't fill those things. I'm just saying it's always going to be P equals some number or mu equals some number. But it's always going to be equals, H naught, always. Then look at your claim. If your claim includes equals, then H naught's your claim. And then H will be the complement. However, if your claim does not include H equals, then H naught has to become your claim. That's a little bit confusing, so we're going to go over some examples, and that'll make it a lot clearer. Here's situation A. Uh, Sterling, can you read? Are you okay reading?
Yeah, I can read.
Thanks.
Situation A. A medical researcher is interested in finding out whether a new medication will have an undesirable side effect. The researcher is particularly concerned with the pulse rate of the patient who takes the medication. Will the pulse rate increase, decrease, or remain unchanged after a patient takes the medication? The researcher knows that the mean pulse rate for the population under study is 82 beats per minute.
Perfect. Thank you so much. So here, what's my claim? And Neil, let me do something first. I'm going to cross out this part because this part's a little bit confusing. The bottom line is you're a researcher. You have a new drug, and you want to know if it has any bad side effects. So you want to know if the pulse rate's going to stay unchanged. Why? Because if it stays unchanged, then you're in good shape, because you do not want to have these bad side effects of your drug making people's heart race or making their heart slow. So what's my claim? What's my hope? My hope is that mu what, guys? Anybody?
You don't want it to change.
I want it to not change. I want it to stay the same. So mu is what? If it doesn't change, it's what?
82?
Yeah, it equals 82. So in other words, everybody else's is 82. My claim is that my mean is also 82. It's not going to change anything. So my next question to you guys is this. Are these two things equal? My claim is mu equals 82. H naught is always going to be equals. So my H naught is going to be that mu is equal to 82. Are these two things the same? Yeah, they are. They're exactly the same. Mu equals 82, mu equals 82. So that means that my claim is H naught. Please note that this number is always going to be the same. 82 is going to be the same number we get here, and it's going to be the same number wherever we get here. The 82 doesn't change. What changes is the equals, the symbol. It'll be the equals, not equal to, greater than, less than, something like that. So these symbols are the same. They're both equals. So that means that H1 has to become the opposite of this. So what's the opposite of equals? Opposite of equals, guys? Not equal.
No, it is not equal.
Yeah, so mu does not equal to 82. That would be that becomes the H naught. That's a two-tailed, because my H1 is not equal to. Situation B, Ashley, go ahead and read this one. Just the first part. Ashley Lau.
For situation B, a chemist invents an additive to increase the life of an automobile battery. The mean lifetime of the automobile battery without the additive is 36 months.
Perfect. Thank you. So he's saying it increases the life of your battery. So he's saying that his is going to make it, is his mean going to be more or less or the same or different? What's he saying? More. It's going to be more than what? What's everybody else's?
36 months.
36 months. So he's saying that his is going to be more than 36 months. So he's saying his mu is going to be greater than 36. Everybody on board with that?
Yes.
Good. So if his claim is that his mean is greater than 36, is that the same as H naught? Are these the same? Look at the symbols. Are they the same? 36 better be the same. That doesn't change. But the symbols, are the symbols the same? No, this is greater than, that's equals. So since H naught is not my claim, right? This one says greater than, this one says equals, then H1 has to be my claim. I have to force H1 to be my claim. So then my claim will be mu is greater than 36. Yep. Everybody following me? Because one of them has to be my claim. Since H naught always equals, it's never a question what H naught is. I have to see if my claim is H naught. If isn't, then I force H1 to be my claim. Because my claim has to be one of them. If my claim is equals, then it's this one. If my claim is not equals, if it's greater than, less than, or not equal to, then my claim is H1. And like I said, very often, my claim is going to be H1. Because a lot of times I'm trying to prove that something is, my drug does something. It increases something or it decreases something. It makes a difference. Let's take one more. C, Selena, can you read this one?
A contractor wishes to lower heating bills by using a special type of insulation in houses. If the average of the monthly heating bills is $78, her hypothesis about heating costs with the use of insulation are?
Right, what do you guys think? You want to lower the heating bills. Everybody else's bill is $78, so my mean should be less than 78. Right, I want to lower it. I'm saying, hey, I can do better than that. Mine's less than 78. So again, is this the same as H naught? No, they're different. This is less than, this is equal to. So H1 has to be my claim. I have to make H1 my claim because one of them has to be my claim. So H1 is my claim. And like I said, very often, most of the time, H1 will be my claim because most of the time I'm trying to prove that my thing does something. I'm trying to prove something. You guys remember like all those people who did all those studies and they tried to get an unusual, and they're hoping for an unusual result so they could write a paper? Like if you get a usual result, then it's something special. You don't write a paper. But if you get something unusual, then you get to write a paper. So very often our H1 is our goal, is our claim. But not always. And on the test, I'm definitely going to give you at least one that will be where the claim is H naught, just so I know that you can handle both of them, both situations. All right, so you guys do problem number 3 on your worksheet. Find the claim in symbolic form. In other words, using, greater than, less than, equal to, not equal to. So here's my claim. Write it in symbolic form. Mu something, something. And then find H naught, find H1. So go ahead and do that. Take a minute or two. I didn't start the recording. If you see where it says mean right there, then you know it's a mean. Okay, so let's take a look at what we've been doing. I have no idea when we stopped. It's probably here. All right, so here, oops. No, go back. Darn it. Okay, so what people got was the symbolic form average is, so is equals, average is mu equals 24.6. Now H naught is always, always, always equals. So that one would be that mu equals 24.6, because remember we're always going to use 24.6 for all these numbers. So since the symbolic form, my claim, is H naught, these are the same, then H1 would become the opposite of that. What's the opposite of equals? Not equals. So H1 would become mu is not equal to 24.6, and that's two-tailed. So we're looking at what your goal is. So if we're rejecting H naught, then I'm going to go through this later. Okay, so this is the part that I kind of forgot to record on, so I'm going to add it in here. So again, if the goal of your test is always to reject or not reject H naught. We're always trying to either reject it or not reject. So here's the thing, you got to think about what happens when you reject H naught. So if H naught is my claim, then rejecting H naught rejects my claim, right? If H naught is my claim, then if I reject H naught, it is my claim. I reject it as well. So rejecting H naught rejects my claim. However, if H1 is my claim, then rejecting H naught is good for my claim, right? If H1 is my claim, then rejecting H naught supports my claim. So these are the words we're going to be using when we do the summary at the end of next week. But right now I want to give you guys just the sort of the intro to it so you get a little bit more familiar with it. So if we kind of think back to our ABCs, you know, A, B, C, D, E, F, G, blah, 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 it goes on and does Q, R, S, T, U, V. So Q, R, S, Q just kind of starts you out. This is just a mnemonic to help you remember it. So just to help you remember, Q, R, S, Q just starts you out, and then R, and then S. That's the order it goes in. Since H naught comes before H1, 0 comes before 1, H naught goes with R, H1 goes with S. So H naught R would be reject, and H1 S would be support. So that's kind of a way to remembering that H naught, when H naught's our claim, we're going to be doing the test to reject or not reject our claim. When H1 is our claim, we're going to be doing the test to support or not support our claim. So in the following, we're going to look at what the goal is of each of these, just to kind of make sure you guys are good with this one. So situation A, H naught is my claim. This is my claim. So I'm doing the test to, am I doing the test to support or reject my claim? In other words, if H naught is my claim, then does rejecting H naught reject my claim or support my claim? If H naught is my claim, then rejecting H naught rejects my claim because they're the same thing. For this situation here, H1 is my claim. So what happens when I reject H naught? Rejecting H naught does what for my claim? Rejecting H naught supports my claim because H naught is the opposite of my claim. So rejecting H naught helps my claim, supports my claim. So I'm doing the test to hopefully support or maybe fail to support my claim, depending on whether or not I reject H naught. This one over here, H1 again is my claim. So rejecting H naught, again, rejecting H naught supports my claim because my claim is H1. So rejecting H naught supports H1. So in other words, rejecting H naught supports my claim. And then we're going to take a look at the test statistic, the test stat. The test stat is your Z-score. It's the Z-score for your sample. So again, if you guys remember you had to find Z-scores, you take your, for a, go ahead and erase this for a minute so you can see it. You take, this is the one we did for central limit theorem, take your sample minus what you expect, divided by the standard deviation. So here was X bar, what we got from our sample, minus what we expected to get, the mean, divided by the standard deviation of a sample, which is sigma over square root of n. Remember, that's from central limit theorem. But we're not going to use that because we're never going to have a situation where we know sigma and we don't know our mean, our mu. Instead, we're going to use this one. So again, it's very similar. Your sample, what do you get from your sample? Your sample mean minus your population mean, what you expect to get, divided by S over square root of n. And then for proportion, it would be p hat minus p over square root of pq over n. That's the standard deviation of a proportion. So we'll go ahead and look at an example. Might make it a little bit clearer. XORT method, that's supposed to increase the likelihood of having a baby girl. So they took a sample of 100 couples, and out of those 100 couples, 58 had girls, 52 had boys. So we're going to use this information to calculate the value of a test stat. So first of all, how many girls do you expect to get? What proportion of girls do you expect to get? You expect to get 50%. So H naught is the proportions equal to 50% because we expect to get 50%. That's what everybody would, normally the population would get. My claim is it's going to increase the likelihood. So my claim is that my proportion, if you take the XOR method, you're going to get a proportion that's larger than 50%. It's going to increase it. So my claim is that P is greater than 50%. So we're going to take a look at, let's see, 58 out of 100 had girls, so that's 58 over 100. My P hat from my sample proportion is 58%, 58 out of 100. So I'm going to find the z-score for that, or the t-score for that, in this case a z-score. So I'm going to take my sample, subtract what I expected to get, 0.5, and divide that by the standard deviation, square root of PQ over N. So here, my P hat minus my P, what I expected to get. And again, remember, we're assuming that P is true. We're assuming that the real value is 0.5 until proven otherwise. So that's why we use 0.5 down here. So PQ, 0.5 times 0.5 divided by N, 100, square root that, and you get 1.60. So you know that, typically a z-score of 1.6 isn't really unusual. Usually our guideline for unusual is going to be right around 2, right? Somewhere in that neighborhood. And 1.6 is not quite enough. So while 58 girls out of 100 does seem like it increases, it's not enough to prove it. It's not unusual enough to say for sure that it is. So, it may be that it increases, but we can't prove it. So we would not reject the H0 because we don't have enough evidence. It's not unusual enough. So we'll kind of look at that a little bit later, but the whole idea of whether something is unusual or enough or not. But it's not, because it's a z-score of just 1.6. Oops. And then we went over this. So you guys, we went over this, I think, together, so that's fine. We'll stop there. Because you guys are supposed to do this problem, which is problem number 3 on your lab. Let's go and go over this. I'm sorry. All right, so Eduardo, what did you get for this one? Or what did you do? Eduardo, are you with us? All right, how about Anjali? What did you get?
Honestly, I was really confused by that.
Okay.
So we're supposed to find score, right?
The z-score, yep. The z-score, so that's called the test, we call it the test stat.
Okay, so would it be 124 minus 120?
No, almost. Very, very close. So remember, it's x bar minus mu. And my mu is this one up here. So over S over square root of N. And again, you guys, the other thing I would comment to you guys is find the bottom part first, and then do this, that minus that, and divide by the bottom part. Because if you do this all in one piece, a lot of times people screw up this whole division part, and it becomes a giant mess, and you end up with like 16 or something totally crazy like that. So, Anjali, what should you have up here? What was it?
So would it be 120 minus 124?
Exactly, 120 minus 124. And then what did you get on the bottom?
Yeah. I haven't been able to figure out the bottom yet.
Okay, so here, sample of, that's your N. And then here we gave you your mean. Sample mean, this is your X bar. And then, and a standard deviation. So this is the sample, this is the sample standard deviation. 4, so that's your S. So it says 4 is my S, and my N is what? 13?
Yeah.
So when you guys do this, you end up with -4 on top, and I think you ended up with like 1.1 on the bottom, 1.1 something. Anybody? 1.11? Yeah. So then I think what people are saying they got was -3.8 If you round it 2 decimal places, 3.36 pigs, it's 3.61. Looks like that's what everybody's getting. All right, and that's the answer. And I think we're going to go ahead and stop there. That seems like a good stopping point. Sorry about that. I kind of screwed up a couple things, but I'll go back and fix those later. So.
Professor Young?
Yes.
Before we leave, can you explain what that answer means?
Oh, yeah, totally. So this means that I got something super unusual. It's 3.6 standard deviations away from the mean. I expected to get 24. Instead, I got something. I got something really far away. If I have a z-score of negative 3.61, that means that here's what I kind of expect to get. And instead, I got something that's 1, 2, 3, almost 6 standard deviations. I got something way out here, really far away from what I should get. I should get something that's I expect to get something that's kind of more in like this kind of range in here, and I got something way out there. So not only is that unusual, that's crazy freaking unusual. So what that means is that statistics professors do not have an IQ of 124. They got something way less than 124. They're definitely not at 124. They're something lower than that. Does that sort of make sense?
Yes. Thank you.
Yeah. Good deal. Right, because again, this is how many standard deviations you are away from the mean. So they're 3.6 standard deviations below the mean. So their mean is not 124, because there's no way that take a sample and you get something crazy like that. The sample, if this was true, if their mean really is 124, I should get something right in this range in here. I shouldn't get something way out there. So IQs as stat professors has got to be less than 124, closer to 120. All right, good deal. Have a great night. Let me just double check and make sure we got everybody here. Eduardo, are you still here? I think I've kind of checked in with everybody else. I think we're all here. Janessa. All right, great. Have a great night. I will see you guys later on Thursday. And just make sure you upload these pages by Thursday before class. So I needed, I think, the quiz, and I think it was page 10 from your notes. That's what I wanted. Just take a picture of those two and upload them. All right, take care. Thanks. I miss you guys. Have a good one. There's Eduardo. Good. Take care.
Good to see you, Professor.
Aw, you guys are great. Take care.
Bye.
Bye.
Have a good one. See you on Thursday.
Thanks. See you on Thursday. Take care. If anybody has questions about the homework, I'll be on for a little bit.